We've all been there. Watch a video for 10 minutes later realize it's a complete waste of time. Or if you're a creator, wishing you had an assistant to read all the comments and summarize. Today we are building this. A fully functional, local YouTube AI agent dashboard. No technical skill required. It is free, you don't need any subscription. This is the AI agent we will create in this video. In the prompt, you have to give only the video unique ID and ask what you want. It will give a response using Flask MCP and Gemma 4 LLM. Python. This is the primary programming language used to develop both the Flask web application and the core logic of the YouTube MCP server. Flask. As a lightweight web framework, Flask is used to build the client application, handling user requests from the web browser and coordinating communication with the MCP server to execute the analysis pipeline. YouTube Data API v3. This API provides the mechanism for the system to programmatically access public video details and comments, as well as interact with private channel details when properly authenticated. OAuth. Standard authorization libraries are used to secure and manage user credentials, allowing the application to authenticate with the YouTube Data API without directly exposing sensitive passwords. Ollama. This engine runs on the local machine to host and serve the large language model Gemma 4. It provides a local API that the MCP server calls to generate intelligent video insights without sending data to the cloud. Gemma 4. This is Google's lightweight, open-source large language model. It is deployed locally to process video transcripts, comments, and other data to generate high-quality text-based summaries and analysis. Fast MCP. This framework is used to build a YouTube MCP server, providing a standardized Model Context Protocol (MCP) interface that connects the local LLM to the tools and data sources like the YouTube API. Here is an architectural breakdown of this tool. Step 1. User request initiation. The user submits a query or YouTube URL via the web browser. The Flask application acts as a gateway client, immediately establishing an asynchronous connection via WebSockets or SSE back to the browser to prepare for live log streaming. Step 2. Tool execution and asynchronous logging. The Flask client forwards the request to the Fast MCP Python server. As the MCP server initiates the pipeline, it utilizes the Fast MCP context parameter to stream live, real-time execution logs directly back through Flask to the browser interface, giving the user instant feedback. Step 3. Parallelized tool fetching and local LLM synthesis. Instead of routing raw fetching through the LLM, the Fast MCP server executes a dedicated YouTube tool. It queries the YouTube Data API v3 to rapidly retrieve raw metadata, transcript files, or comment structures. It feeds this raw context along with the user's prompt directly into the locally running Gemma 4 model via Ollama. Gemma 4 processes, synthesizes, and formats the video insights locally on your machine. Step 4. Final output rendering. The MCP server packages the highly structured, markdown formatted final response and transmits it to the Flask web app, which instantly renders the polished result in the user's browser. Make sure you are in the virtual environment and have this folder structures and files. Go to the terminal and start the MCP server. In another terminal window, go to the project folder, activate the virtual environment, and run the client application. Go to the browser, and you should see the application running in port number 5001. Now let us do some testing. Let's grab the 5 most recent comments from a video and have our AI agent summarize them. All you need to get started is the unique YouTube video ID. You can easily find this in your browser's address bar when you open the video. It is simply the last 11 characters of the URL. Let's plug that in, and just like that, the tool has successfully summarized the comments for us. Beyond just analyzing the comments, you can also ask the tool to grab the video's title. As you can see, we now have both the video title and a clean comment summary displayed side by side. Best of all, you aren't limited to just 5. You can ask the tool to retrieve and summarize any number of comments you want. This is Virtual World Voyager, a popular gaming channel packed with guides on how to play The Legend of Zelda. Instead of heading over to YouTube, let's see how we can pull their channel info directly using our tool. When you're browsing YouTube and spot an interesting video, click on it and grab its video ID. Those are the last 11 characters in the URL. Just drop that ID into our tool's prompt along with your question. For instance, you could ask, how many subscribers does this channel have, and when did it start? Also, what are its 5 most popular videos? Within a minute, you'll get a breakdown of the channel's top content without having to scroll through their entire video tab. When you're watching a video, that unique 11-character ID is right there in the URL after the equal sign. Alternatively, you can easily grab it from the video's share menu. If you have a popular video on your channel, you can easily use this tool to run a sentiment analysis. For videos with hundreds of comments, you can even extend the tool's functionality, setting it up to run on a regular schedule and automatically email you the analysis reports. This is the Model Context Protocol, MCP, server code, where each Python function defines a unique tool designed to handle specific prompts. You can easily extend the server's capabilities by adding your own custom tools to the codebase. This is the Flask-based Python web client that interacts directly with the MCP server. If you want to customize the user interface, you can easily do so by modifying the HTML templates. This sample JSON file contains the client ID and client secret required for YouTube API authentication.
Thanks for watching. Like and subscribe if this video was useful.